All right, we're going back a couple hundred years to Isaac Newton and his classic demonstration passing white light, that is sunlight, through a prism, separating it into different colors of the rainbow. But then about 100 years after that, Johann Ritter in Germany found that he could go past the violet end of the rainbow. Interestingly enough, he held some silver chloride paper, sort of photographic paper, next to the blue end of the spectrum, that is the violet end, and the paper was still exposed. He had discovered something that was beyond the violet end of the spectrum. He had discovered ultraviolet light. Well, ultraviolet light is fascinating, sometimes called black light. And in 1934, Joe Switzer, a magician, put this to a very interesting use. There are some substances that will fluoresce under ultraviolet light. They absorb the energy of ultraviolet light, and some of that energy is re-emitted as heat and as visible light. So these substances glow under ultraviolet light. And he designed a magic illusion based upon this. It's something that today you often see in what is called blacklight theater. Here's a classic example of that, where you see headless people dancing around. Well, that's the illusion that was created way back in 1934 by Switzer. And he had developed dyes that fluoresced under ultraviolet light. And of course, he was able to make use of this on the stage in a very interesting way. And you may have experienced this if you've ever been to a disco where there's black light. You will see that there are some objects that glow under the black light. Why do they do that? Because there are some fluorescent substances in there. For example, today laundry detergents contain optical brighteners. These absorb ultraviolet light, re-emit visible light, so it makes things look whiter than white, brighter than bright. Interestingly enough, you can do fascinating things with ultraviolet light. But let's keep in mind that excessive exposure to ultraviolet light is not good. This is what can cause skin cancer. Now, not with black light. Those wavelengths are okay, but you don't want the damaging wavelengths of ultraviolet light that come from the sun, and that, of course, is why we take protection. Well, this development of these fluorescent dyes was so important that the American Chemical Society actually recognized the place where the Switzers first worked as a landmark. And it's not often that the American Chemical Society recognizes a location as a landmark, but the invention of fluorescent pigments was such a thing. Today, of course, they're all over the place. You see policemen, construction workers, all wear these garments that are fluorescent, and because they absorb ultraviolet light and re-emit some of that is visible, making things brighter. Now, I can't show you the original Switzer illusion, but I can give you an idea of how it worked. Because suppose that you have black light shining on here, you see absolutely nothing, until something appears that can absorb the ultraviolet light and reflect it as visible light. So you might see something like that appearing suddenly. Now, this wasn't, of course, done with ultraviolet light, but the principle is the same. And I'll give you a hint. It is done with black velvet. So now you can think about how they might make use of that on the stage in blue light theater. So all the way from Isaac Newton to dancing in a disco and watching your shirt fluoresce.